Bodhyan. So this one, as Pijan alluded to, started 5 years ago, where Professor Jawahar and Anbu and others put together what we call an Indian driving data set. This is the first driving data set of Indian driving conditions. Until then, most of the driving data sets were of US, Europe, or Western world. So this has been very good since the past 5 years. They have put a lot of data sets out there. We have thousands of users out there. But those data sets are mostly based on simple cameras. Now we're going to extend it. So this Bodhian platform will have not only just regular cameras, lidar, radar, and infrared camera, so that the whole data set will have a lot more dimensions. Not only that, we're making this a platform so that other partners can take this and use their own sensors or use these sensors and do their own data sets. We've been having conversation with GHMC and others so that they can do their own data sets, right? For cleanliness detection automatically, pothole detection, multiple use cases. Right? Second project, Rajesh will talk about the microlabs project.
Good morning, and happy to be sharing what we intend to do under the micro lab. So as the name suggests, it talks about a lab which is micro in nature. So it means that we intend to set up labs which is closer to the samples which require to be investigated. And in this case, we intend to do that investigation using genomic means. So what is the requirement for the day? What we understand in last 2.5 years, much more than before, and that is the importance of whether we can combine three P's in terms of putative severity, predicted severity, and whether we can do something which is preventive in nature. So using this setup of microlab, we intend to catch the mutations within the pathogens for their potential disease severity in the future. And how do we intend to do it? So if we go to the next slide. So that's what we want to do, that we want to read the book chapters, which is what is written within the pathogen genomes in terms of how many chapters are there, what are the different lines and what are the different alphabets within that chapter, and that is what the microlab will do. And how do we do this? By a machine which is literally I'm carrying, we can carry in our bag, in our pocket, and that's a nanopore sequencer, and that's what it does in real time. That when we put a DNA template through the machine, which essentially has nanopores, and they will pass through that nanopores, and it will be sequenced in real time based on what? Based on the electrical differences of the bases passing through that. And that's what we are going to implement it here. And next slide, please. And the additional advantage is that we can do many more samples together. And if we just go click on it, how do? We index many things together. So all of us here, we are wearing, say for example, different color of shirts. And that's what essentially we will do. If we want to know what potential bacteria we may have, we will mix them and we will label them with something unique to each of them, pull them together, sequence them, and again after sequencing we will differentiate the different colors based on the indexes which we have done. And once we complete all of this, that's what we will do. And that's where we intend to, it's a 3-year roadmap where we will use the genomic surveillance to first detect and then develop it into diagnostic regions of the pathogen genome, which will be used for preventive and diagnostic purposes, that whether if an individual has particular mutations or a particular pathogen, how do we identify or catch those individuals which may have a severe form of the disease at later point of time, and that's where we intend to be over a course of next 3 years. Thank you.
Uh, Raj.
Thank you so much, Rajesh. IGP has been a fantastic collaborator through these years. In the past and more recently since COVID, with the Gandhi Dataset, Gandhi Hospital COVID Dataset project jointly with IGP, and since then some more, and now we are launching yet another project. So request Dr. Hemant Gautam, Director of IGP, to share his thoughts.
Good morning, sir. Honorable Minister KTR Ramarauji, IIIT Director Narayanji, and other dignitaries on the dais and the audience. The work micro lab starts when the COVID time. You just imagine that everything was closed. Only IGY was working, particularly Dr. Rajesh lab, 24-hour working, and the seed was grown there and fruits come out today. So for this, I thanks to Telangana government and IIIT who believe us the technology, what we can do. So the technology we have developed during the COVID time is time consuming, very quick methods to identify the bacteria, virus, any places. So sir, this will help you for your agriculture department, for a health department, anywhere, any microbes comes. If unable to identify this technology, we can identify within 6 hours. We can tell which antibiotics, what is the things, what is the new one. So this is the application. Same application you can apply for the agriculture also. So anytime, if I wish pandemic should not be there, but this is natural ways. So pandemic comes anytime, anywhere. You just give a call. Within the 2 days, we will tell you which microbes is there, from where it is coming. We will also tell the source of microbes, where it's coming, and what could be the harmful for the future time. So you can plan the administration or other official can plan how to inhibit the growth of microbes, how to kill the microbes. So this is the technology which will help for the general people. Second things, during the COVID, we faced the transport, collection of sample and transport. So we don't have any person everywhere where we have a doctors or nurse, they can take the samples.